So now that we've got the internet backbone, the MPLS network, and layer 2 up and running, now we jump into the core of the practice exam itself. And this is where I think the challenges start to really ramp up a little bit. In this particular video, we're going to be focusing on the Customer 1 sites task, because this Customer 1 is primarily focused on OSPF. So this challenge is going to be highly centered around OSPF and how we can manipulate and engineer OSPF throughout the entire topology. Get ready, it's going to be big and it's going to be fun, and I'm going to get stumped towards the very end, but don't worry, I'm going to fix it. Hang in there and watch it till the end. I'll see you in there. All right, everybody, welcome back. We're diving back into the CCIE playlist. This time, we're going to be standing up Customer 1. That's the majority of the pink sites that we're looking at here, with the exception of the SD-WAN stuff. Now, before we get into this, if this is all kind of new, if this is all kind of fuzzy, if you're looking for training, you want to check out CBT Nuggets. The description is in the link below, learn.gg/DataKnox, or you can just go to cbtnuggets.com. Definitely give that a check, because this is where we're now testing our skills. So if this is all kind of new, if you want to, maybe you'll pick something up new along the way. I hope so. But maybe if you want to do some actual like learning and studying, that's where you want to start. So now we're focused on Customer 1 here, and this is going to be primarily an OSPF task. Let's actually bring up the lab task for the Customer 1 sites. I'm going to kind of stick it in the middle for right now. So we see here kind of the tasks that are ahead of us. We're going to be configuring individual sites and areas. I see redistribution sticking out here and there. I see some filtering listing out. So we're going to have a lot of fun. Let's see here. You know, let's just kind of set everything up. Let's bring up all the routers. So I'm going to bring up the routers in numerical order, starting with router 6, then 8, then over here on 10, and 12. Let's see what else I got. I think I'm now going to go to 15, 18, 19. Yeah, that's right. 15, 18, 19, and then 42, 43, 44, 45, 46. Okay. Oh, too many 42s. 43, 44, 45, and 46. So that should be all the routers that I need to work with in this topology. There we go. So let's kind of slide this over a little bit here so I can just keep my eye on it. Maybe slide it over a little bit more. Maybe a little bit more so we get a better view of over here. We'll come back to the other sites when we need to. Yeah, there's not a really easy way to kind of show these things. So can I shrink this? Oh, okay, that's better. Yeah, I didn't realize I could do that. Okay, cool. Learn something new every day. All right, cool. What if I do one more? You know, getting greedy just to see. Okay, yeah, we'll work with this. Okay, configure OSPF area 0 at Customer 1 sites 3, 4, and HQ. So that's here. That's the purple, the two purples here with the backbone. Minimize the number of LSAs that would be flooded throughout the topology. So don't use redistribution is the first thing that tells me. Maybe even do point-to-point links, point-to-point network types. So that way we don't need a designated router and backup designated router on those interfaces. Ensure that adjacencies would not be formed over WAN interfaces, so that's passive interfaces, and ensure that all routers calculate the cost based on gigabit interfaces. So that's going to be the auto cost reference bandwidth. So let's start up here with router 10 and work our way down to router 12. So get a lay of the land, show IP interface brief. I'm looking at interfaces 2 and 3, 10.0.14 and 10.0.144. So let's go into this and do router OSPF 1 and give it a network statement 10.0.14.0 area 0, and then 144 area 0. But I'm now going to go into interface range E023 IP OSPF network point to point. So now on switch 33 and 35, I'm going to do basically the exact same commands. So let's do switch 33 and 35. So switch 33 is up. Let's first make sure IP routing is even turned on. IP routing, IP routing. And now let's go to interface Ethernet 00. IP OSPF network is going to be point to point. router OSPF1 to show IP interface brief. Network 10.0.144.0. Yep. Okay. That should come up pretty quick because there's not going to be a designated router and backup designated router election. There it is. All right, switch 35. Very similar treatment. Which I already forgot what that treatment was. Interface Ethernet. Oh, IP routing. That was the first one. IP routing. Interface Ethernet 00. IP OSPF network point to point. And router OSPF 1 network 14.0. Okay. Let's make sure that comes up quick. Show IP OSPF neighbors. Xstart, it's usually a good sign. The exchange is happening. To debug IP OSPF adjacency. That was okay. There it is. Well, I feel like that neighbor relationship should have came up a little bit quicker there. Okay, so there was some sort of like software issue with the lab, and I spent all this time troubleshooting when I literally just deleted the link and re-added it, and as soon as I re-added it, it went from loading to full. So something just went wrong with the software in the lab. Sorry for the editing that I had to do there. I wasn't being dishonest. It's just you know, at some point when things like, you typed it right a million times and it still doesn't work, then, you chalk it up to like, maybe it's a lab problem. So sure enough, it was a lab problem. I literally just deleted the link and re-added the link. And sure enough, I see I've got the, state loaded to full right there. So anyways, do undebug all. So there we go. Case closed, just software. Turn off all debugging. Okay, so minimize the number of LSAs that would be flooded throughout the topology, ensure that adjacencies would not be formed on the WAN interfaces. So I need to turn off I need to turn passive interface on E01 and E00 on router 10 here. So let's do router OSPF 1 and say passive interface default, no passive interface E02 and 3. And then I'll do the same thing, as a matter of fact, down here on R12. So let's jump over to R12 for a second. Take a look at its interfaces. Router OSPF 1, passive interface default, no passive interface E02. Let's just turn on that network statement for E02 as well. And this is also going to be in area 0. Cool. So now we need to bring up let's do R19 next. Show IP interface brief. Maybe. Okay. Big T, router OSPF 1, network 10.0.13.0. Okay. And 10.0.0.19. E01 is what connects into the headquarters section here. So now R43, before I jump into R43, I see it's only got, we didn't specify that site 5 should be in area 0. So I need to configure this interface E00 to be in area 0, but I don't know what 2 and 1 have in store for me just yet. So on R43, let's do router OSPF 1. Oh, let's also get a do show IP interface brief. Okay, so E00 is 10.0.0.0. That should bring up that. So this is also a broadcast domain right here. It's not a point-to-point link, so I can't minimize the number of LSAs that are right there. I guess I could do a point-to-multipoint, but I'm going to leave it as broadcast for right now. Yeah, that's what I'm going to do. Leave it as broadcast. Let's jump over to R42 and get it brought to life. Let's do show IP interface brief. Cool. Let's bring it up here. OSPF1 network. It's in area 0, and I'm also going to get 10.0.10 brought to life, which is what goes into switch 36 over there. So now I need to get switch 36 brought into OSPF and then exchanging routes with 33 and 35. So let's jump over to switch 36. And do show IP interface brief. Router OSPF1. Let's bring VLAN 10 into life here. Got to spell OSPF correctly. Network 10.0.10.0. Okay, so now switch 36 is trying to form a relationship on VLAN 10, which it'll form here with R42, but now we need to get VLAN 10 brought to life on R33 and R35, so that the routes from R10 make its way all the way into R42. So let's do that. Let's go to R33 and R35. Our OSPF1 network 10.0.10. And same thing on router switch 35. Let's just copy and paste that because I don't want to type it. Might have honestly been quicker to type it. Okay, there we go. So all these OSPF adjacencies should be coming to life at this point. What I need to do now, though, is I also need to bring in these WAN interfaces into OSPF. Since I have passive interface on, they won't be sending hellos out, but I do want them to be advertised into OSPF. So let's make that happen too. Those are going to be 192s and 192s, right? Do show IP interface brief. Yep, 192s. So let's just do network 192.1.0. 255, area 0, and let's bring that to life over here on 12 as well. Okay. So now we should feel good and converged at this point. Let's make sure switch 35 had some loadings, switch 36 had some loadings, looking good. You know, sanity check. From R10, show IP route OSPF. Okay, looking pretty good. Let's see, I've already, the routes from R12 made its way all the way through. I can see I can get to the 1010 network. Looks like it goes through the switches for pretty much all of these. The switches then take it to the, yeah, let's just try. Ping. 192.168.12.12 round trip. So that looks good. If I trace route, let's make sure it went the right way. 192.168.12.12. Oh, it's so slow to trace route sometimes. I really don't want to sit here and wait for this thing to trace. So I'm just going to do Control C and Control Shift 6. And we'll take a look at the lab tasks and move on from here. We've got ping ability, so I'm just going to trust that it works. We've got a lot of stuff to do. We're still, oh yeah, we did auto cost reference bandwidth. Okay, we're still on step 1. Router OSPF1, auto cost reference bandwidth. Is this in what speed? This is in megabits per second. So we need million. And we got to make sure this is consistent, it says. Switch 35, switch 36, switch 33. Oh, yeah, just do it around the horn, right? Router OSPF1, because it says we got to do this for every device in the domain. So let's just take it one at a time. T, router OSPF1, paste it in. I think we already did it on 10. Need to do it on 12. Router, not touter, router OSPF1. Set the router reference bandwidth there. Router OSPF1, set the reference bandwidth here. 19, 42, 43, 44, router OSPF process ID 1, paste it in. 45. Router OSPF 1, paste in on a cost reference bandwidth, and 46. This should do the trick. Router OSPF 1, paste. Okay, cool. Reference bandwidth is consistent across all routers. Done. Configure Site 5 for OSPF as Area 51. Okay, so Site 5 is... Ooh. There we go. Bring this back. Let's just kind of thumb over a little bit. Site 5 is going to be 43, 44, 45, and 46. That's going to be Area 51. Notice that the next step, Area 51 should not allow the propagation of LSAs 4 and 5. So we can't allow that's not right. We can allow redistribution in a NSSA. Those will be LSAs type 7. It doesn't say anything about LSAs type 7. So that's what I'm going to stick to. We're going to make this an NSSA. So let's first create our area, which is going to be 10. These two interfaces here, 0.1 and 0.2. So let's say 10.0.46.0, 255 area 51, and 44.0. And we're going to say area 51 in SSA. Cool. So from 44's perspective, if I do show IP interface brief, I will say network 10.0.44. Actually, you know, I said 45 earlier, but 45 is not in Site 5. That's outside. This is an external router. So we're only going to do this on 43, 44, and 46. Area 51 in SSA. And 46, we'll do show IP interface brief. We're going to say network 10.0.46.0, area 51 in SSA. Cool. So we've got the NSSA stub area set up here, and we are not permitting LSAs type 4, which is the ASBR LSA, and type 5, which is the external LSA, but we are allowing type 7, which is the NSSA external LSA. That's so many letters. All right, so I see the OSPF adjacencies coming to full now. So 43 has converged with 44. It should be converging with 46. Let's do show IP. I hope I'm not running into another one of these issues. Oh, looks like it may have already come. There it goes, right there. Full, okay, cool. So now jumping across the topology, let's go into configure OSPF area 1 on site 1. So let's scroll over. This is between 6 and 18. Okay. Do show IP interface brief. We're going to do, so this one has WAN interfaces. Recall our instructions above, where we have ensure that adjacencies are not formed over WAN interfaces. So R6 has WAN interfaces, so I am going to set passive interface there. I'm going to say no passive interface for Ethernet 02. And now I'm going to specify my statement of 10.0.11.0, and this is going to be in area 1. I am also going to bring in those WAN interfaces into area 1, of course, without advertising those hello packets. Oops, 255, area 1. Okay. It does give me some authentication requirements here for Site 1. Use HMAC SHA authentication with password data Knox. Password should expire on January 1st, 2021 and roll over to data Knox. Ew. Man, keychain 1. Let's call it OSPF. Key 1. And let's first set the cryptographic algorithm to HMAC SHA 256. Let's set the key string to be, what was it, data Knox. Now we need to set our accept lifetime, which is going to be the start time. We can just set this to be right now. And then we specify the date, right? January 1, 2020. No, that's not right. This is not right. Let's see what we're trying to do. We're trying to do the send lifetime, is going to be starting right now. On January 1, 2020, and we will have it go towards up till January 1, 2021. So January 1, 2021. And now we'll do the same thing for the accept lifetime. That's right. So our accept lifetime will be for this year. Accept lifetime. Cool. Okay, so that sets up this key to be sent and received for the year of 2020. Oh my gosh, Windows updates. Why are you like this? Okay, let's now go into key 2. The key string is data Knox 2 or data Knox 1. The cryptographic algorithm is HMAX SHA 256. The send lifetime is going to be starting January 1, 2021, forever. Same thing with accept. Cool. Now we can go into that interface and set that OSPF authentication, which is on Ethernet 2. IP OSPF authentication, IP OSPF authentication keychain. We named it OSPF. Okay. Now let's jump over to R18. Bring this whole thing. Okay, you know what? That was a lot to type. So here's what we're going to do. R6. Do show run. Section key. Okay. Grab all of that. Back to R18. Paste it all in. And interface Ethernet 00. IP OSPF authentication. IP OSPF authentication keychain OSPF. Now let's bring OSPF to life. Show IP interface brief. Router OSPF 1, network 10.0.11.0. And this is in area 1, right? There it is. Came to life. Cool. Area 1 is done. Step 6, configure OSPF area 2 on site 2. Use MD5 authentication. Let me move this a little bit. There we go. So this is between 8 and 15. Okay. Let's bring this to life with MD5 authentication using password authentication. So let's start by doing this. Bring in OSPF to life. Router OSPF 1. Again, this has WAN interfaces. So turn that off. No passive interface Ethernet 02. Now I can start advertising my networks. 10.0.12.0. This is in area 2. Uh-oh. 255. I'll also do the 192 networks. Nope. 255, 255, 255, area 2. Okay. And now I'll do the authentication. IP OSPF authentication message digest. IP OSPF authentication. Nope, this is IP OSPF message digest key 1 MD5 data Knox. Bam. Okay. So let's grab that real quick. Do show run interface Ethernet 02. I'm just going to copy the authentication stuff here. And this is going to be on R15's E00. So let's go into interface E00, paste that in, and then back over to router OSPF 1, network 10.0.12.0, area 2. Again. Adjacency. Let's watch it come to life. Oh, loading to full. Too quick. Okay. Very cool. So now we've got that brought to life. Advertise all loopbacks into OSPF. Okay, cool. Here we go. So, going to take a while to advertise all of these loopbacks here. Do I even have a loopback on R6? Do show IP interface brief. Don't even have a loopback on R6. That's no good. Let's make one. IP address 6.6.6.6, 255, 255, 255, 255. I could also clear the OSPF process right now, so it takes that new router ID into consideration, but I don't need to. Why do that? Network 6.6 000 area 1. I don't think I have a loopback here either. Man, got lazy. Add that loopback real quick. 255, 255, 255, 255. Jump back into OSPF 1. Network 8888 000 area 2. Okay. Here we go. Router OSPF 1. Network 10 10 10 10 000 area 0. Router OSPF 1. Network 12 12 12. Yeah, I forgot the periods. 0 0 0. Oh man, this is when I wish I could just use network automation. Please, just let me do it. Just get the loopback ID and run these statements. Actually, you know what? There is an easier way to do this. Instead of sitting here typing all this, let's make this the quicker way, right? Interface loopback 0, IP OSPF 1, area 0, I think is the command that we need to do. Yep. Okay. Okay. Yeah, much quicker. Okay, before I mess this up, 42 is there, 43. I'm going to advertise this loopback into area 0, even though this one is in 2 areas. And 44 and 46 are in area 51. So let's fix that real quick. 1 and copy that. Yeah, 44 and 46. Cool. Loopbacks are brought into OSPF now. Prevent R19's loopback from entering R43's route table, but ensure it is forwarded into R51. So we're talking about a distribute list. Since R43 is an AVR, we can stop it from adding that route into its routing table, but it will forward it on because it's in the link state database. And it would send in a summary route too at that point, I believe. So let's do that. So on R43, let's do show IP route, verify that we have 19 right there first. Okay, let's do IP access list standard. Let's call this R19. And we're going to say permit host 19, 19, 19, 19. Now we're going to make a route map. Route map, let's call this R19 loop and call it deny. Sequence 10. Let's say match IP address. What do we call this? R19. And now let's create our catch everything else. R19 loop permit 20. Okay. Now when I go into router OSPF 1, I can create a distribute list, and we are based on a route map, which we called R19 loop, and this is going to be inbound. So let's do exit, clear IP route, right? Let's just do it. Clear IP route start. Let the route table bounce here. And sure enough, 19 is now out of the routing table. Did it stop it from reaching R44? Show IP route. And 19 is still an inter-area route here on R44. So good news. Step 8 is done. R19, R42, and R43 3 should verify that their neighbors are directly connected. So back in the HQ, we're doing TTL security now. We need to check that they are directly connected. So this is going to be the TTL security. So let's say TTL security, all interfaces, hops 1. So when I do this on 19, it's also going to take down my neighbor adjacency to 12. So I am going to have to set this up on 12. And similarly, when I do this on 42, it's going to break my connection to switch 36, which is going to break my connection. As you see, it's going to break all the way down the chain until we get down to that. So yeah, we're going to have to do more than just 42, 43, and 19 here. But nonetheless, this is good times. So 19, let's just copy this. That way we can do it all over the place. Router OSPF 1. Router OSPF 1, paste it in. We'll do this here. Oop. Here, router OSPF 1, oop. 46. Paste it here. Switch 36, we're gonna do it here. Config T router OSPF 1, paste it here. 35. Paste it here. Switch 33. Yeah. Router OSPF 1. Paste it here. And then all the way down here to router 10. Oop. Okay. So, who expired here? 19 to 12. Forgot 12. Forgot 12. There we go. I should bring it back up. So let's see if that, yep, that brings it right back to life. Okay, so now TTL security is everywhere. So that really, they wanted us to do it in just one section, but we really had to do it everywhere. Anywhere there's a neighbor relationship, it has to be in two directions. Okay, so now we're on to step 10. Prevent R42's loopback from entering R43's table and ensure it is also not forwarded into R51. So now we're doing a filter list. So let's see, that's R42's loopback. So just like we did before, IP access list standard, let's call this R42, and we're going to say permit host 42, 42, 42, 42. Let's exit out. And let's do another route map. And we'll say this is going to be R42 loop, deny 10, match IP address R42, and then route map R42 loop permit 20, exit, router OSPF 1, distribute list, route map, we said R42 loop in, and we also need to do a filter list. So let's do filter. Filter list. Is filter list done on the interface itself? Or is it area 51 filter list? There we go. We filter it at the, oh, do you have to specify a prefix list? Yeah, okay, cool. Well, must be a prefix list for a filter list. So distribute list can do anything, but filter list must be a prefix list. These subtle nuances are what always gets me. So let's call it R42 prefix, just to be safe. We're going to say deny should we say permit, because the filter list is what's going to do the filtering. So let's do 42, 42, 42, 42 slash 32. Okay, router OSPF 1 area 51 filter list prefix R42 prefix out. That is definitely the wrong direction, but don't worry, I'm going to figure it out. We are talking about filtering routes as they come into Area 51, though. Now, just for fun, let's do clear IP OSPF proc. Yes. Make it bounce all the neighbor relationships, bring them back into the full state. 44 and 46 came right back to life. So here, do show IP route, and I no longer see 42 or 19. So that's cool. So that's good. So that means R44, we've now got our filters working correctly. So let's see, that's done with 10. Configure EIGRP between R44 and R46, the remote router R45. Okay. Router EIGRP doesn't say what autonomous system, so I'm just going to call this 101. And do show IP interface brief. This is going to be network 10.0.45.0. Cool. Jump to router 45. Show IP interface brief. Config T, router EIGRP. We said this was autonomous system 101, network 10.0.45.0. This will come up because EIGRP is so stinking fast. And we'll start it running on R45. Router EIGRP 101, network 10.0.145.0. And that'll bounce really quickly. Boop, there we go. EIGRP is up and running. Redistribute EIGRP routes into OSPF, ensuring that the path is calculated throughout the OSPF topology. So that means it's got to be a metric type 1. So, and we're going to redistribute on 2 points here. So let's go back to OSPF, router OSPF 1 on R44. We're going to redistribute OSPF subnets. Nope, we're not redistributing OSPF. Redistribute EIGRP 101 subnets. Metric type is going to be 1. Let's set the metric to be 10 since, you know, why not? We're directly connected to it. You know, it's gigabit, so let's do that. Redistribute metric type 1. So we're going to do the same thing on 46, router OSPF 1, redistribute it inbound. So now from R10's perspective, that LSA should be making its way all the way here. Because this was a NSSA, we were able to do the redistribution. Good thing we did it correctly in the first place. It hasn't made its way here yet. Let's see what's going on over at R42. Show IP route. Still haven't learned about these routes. Show IP route from R43's perspective. There's my N1. So this should now be getting turned into an E1 and sent to R42. Why is it not? Why is it not? That's pretty weird, isn't it? Take a look at this one more time. On R43's perspective, it's learning about these. So this should have been turned into an E1 route sent through the rest of the topology. The last step here is ensure that R45 can respond to pings from the OSPF domain. So R45 wouldn't know about any of these routes in OSPF right now, right? Because we haven't sent any OSPF routes into it. So we can do the redistribution here and say redistribute OSPF 1, but then we have to specify the metric, or otherwise it's going to be an infinite metric. So bandwidth in kilobits per second. Just something gigantic, million. Delay 1, reliability 255, load 1, MTUs 1500. And let's redistribute on 46 as well. Router EIGRP 101 and paste it in. Okay, so now if I do show IP route, I got all these external routes looking good there. So 43 should have sent 145 and 45 into area 0 because it is the NSSA border router. Or show IP OSPF database. So from R43's perspective, show IP OSPF database. Okay, so let's do show IP OSPF database. And okay, so I think something's going on with this NSSA configuration because I see that I've got the type 7s here. But I'm looking up here in area 0 and I don't see any summary addresses. R43 should be creating summary addresses and sending those into the topology. So if I do like show IP route here on R19, see, I should be able to see summary addresses. So there's something going on with the NSSA configuration where R43 is not sending any summary addresses whatsoever inbound. This could be a like software issue. So if I say no area 51 NSSA, no area 51 NSSA, same thing with over here in R46, no area 51. Oh no, I got to get into configuration mode. Router OSPF 1. No area 51 NSSA. The process bounces, but now on R43, if I do show IP OSPF database, see, now I have summaries. And if I come back to R19, do show IP route, now I see the E1 addresses. So the external routes do make their way in whenever I remove the NSSA configuration. So I'm not sure what's really going on there. When I configure NSSA on R43, it knows it's an autonomous or an ABR. So if I do show IP protocols under OSPF 1, right there it is an area border router. It knows that it is an area border router. But when I do NSSA, it is not behaving like an area border router. So I'm not sure. I really think that's going to be, I'm chalking this one up to a software problem here. So there were a couple of important things that got me there in that last part, wasn't it? So let's do this. Let's do show run section OSPF first of all to bring this up. So I already identified that this was the issue, that we needed to be sending this prefix list, filtering prefixes as they come into area 51. The direction really did matter there, but the prefix list itself was also incorrect. Let's do show run section prefix, and we can see here this is how the prefix list really needed to be set up. We needed to be denying this first prefix, 42, 42, 42, 42, but then permitting everything else as it comes in to area 51. So now when I jump over to a device at area 51, like router 44, I can press enter, and I see that I do have all these inter-area routes, but I don't have 42, 42, 42 set up. Let me also jump back to the topology real quick. We'll go over to 42 and give it a show IP route. And sure enough, I actually have the external route listed here, the E1 route. So that way we actually do see that that route is coming back in. Of course, that's also all validated now by the show IP OSPF database. So we can actually see the summary route showing up in area 0 here. There they are, the summary routes, as well as the conversions from the type 7 to the type 5 for this route right there. So there we go. That was the fix. There were a couple things that tend to get me, and that's in prefix list, access list, and route map. Should it be a permit or should it be a deny, as well as the directions. Should it be in or out? And it's kind of when you combine all of them together, that can actually get really confusing. So this is one of those things that you're really going to want to nail it down when it comes to exam time, because, 2 plus 2, in my mind, sometimes end up being 5. I don't know. So there you go. That's the real solution there. All right. Thanks for stopping by, y'all. I'll see you in the next one.